For lesson 25, we are talking about this thing called the measure of central tendency, as well as the measure of dispersion. Let's talk about the first one. Measures of central tendency. You know, what is the likelihood of something going to happen? Essentially is what we're looking at here. And what it comes down to is the measure of central tendency is made up of three things. It's our three M's, the mean, median, and the mode. So I'm not going to spend a lot of time with it, with these three. Mean, also known as the average, add up all the values, divide by the number of values that we have, correct? Median, what does that mean? The middle number. Okay, the median in the road occurs in the middle of the road. And the mode represents the one that occurs most often. So let's just take a minute or two to go ahead and find the mean, median, mode for the following list. Answers that we came up with for the mean. 17.7. Do we agree? Hopefully so. How about for the median, the middle value? Now suppose we didn't have this 20 here. Let's talk about this case. Suppose we have an even set of values. Now what would the median be? Yeah, we identify the middle two values, which is 17 and 18, and then we would take the average of those, which we know the average between 17 and 18 is just going to be 17 and a half. Mode? 19. That is measure of central tendency, your three M's. Measure of dispersion. Once again, we're looking at three items that make up this category. The first one is the range, which we know how to find the range of a data set. We simply take the greatest value minus the least value. Then we have these probably two relatively new terms that we need to talk about. Something called the variance and something called the standard deviation. The variance of the data is the average of the squared differences from the mean. And to make it easiest for you, the variance is simply, let's see if I can do this. We have a red one. Well, let's go purple. The variance is this right here, which is something you'll need to get in your notes. Can we still see that with the purple highlighter? Let's try and go this way then. Good enough. Variance is x of 1 minus this bar with x, or the x with the bar over the top of it. What in the heck does that mean? Well, this represents the mean. So we're going to start with the first value in our set, subtract the mean away from it, and square it. And then we're going to do that for the second one. X of 2 minus the mean squared. We do that all the way down the line till we reach our final nth term. And then we'll add all of those squares together. And then it's kind of like the average. When we're all done, then we're going to divide by the number of terms that we have within the set, n number of terms. The standard deviation then is nothing more than taking the square root of the variance. And we denote standard deviation with our Greek letter sigma. So that's what that is. So when it comes to variance and standard deviation, the variance is what's going to take 95 to 98% of the work. We got to do all of this stuff on the inside. And once we have the variance, now we just take the square root of it to come up with our standard deviation. And really a basic definition of standard deviation, it's just the measure of the spread of the data. You know, how widely spread are these values? Are they widely spread? Are they close to one another? And so forth. Are they very concentrated? Are they very spread out?
What's that symbol on the line? Is that just O?
Sigma? Yep. Just represents standard deviation. Kind of like that. Sigma just means standard deviation. So let's go ahead and do range, variance, and standard deviation for this set. I'll walk through it with you. If we start with the range, greatest minus the smallest, it looks like my greatest value is 17, smallest value is 5, range is going to be 12, easy enough. Variance, here we go. Big fraction bar. And again, if we go back to the definition, it was always the term minus the mean. So let's go ahead and find the mean first. So we can plug that in right away. What is our x bar going to be? Answer that we came up with, Abby? 11? Yep. So when you find the variance, you actually need to find the mean first. And now what we're going to do is we're just going to start with the very first value, which is 5, minus the mean, and we'll square it. Plus the next term, 7 minus 11 squared, plus 12 minus 11 squared, plus 14 minus 11 squared, plus 17 minus 11 squared. And what am I going to divide by? The number of terms that we have there. Yep, so how many terms do we have? It looks like we have 5 of them. That's what that n value represents. How many n terms do we have? So yeah, a little bit of calculation now. A lot of these we actually can do in our head. You know, 5 minus 11 is 6. And it doesn't matter whether it's positive or negative, because when we square it, it'll just turn out to be a positive 36. Difference between 7 and 11 is 4. 4 squared is 16. Difference between 12 and 11 is 1. 1 squared is 1. 14, 11, 3, so 9. 36 again. True. Let's go ahead and find the decimal that this is. So if you would take 98 divided by 5. One more time.
19.6.
Okay. And now what we want to do is go ahead and find the standard deviation. Hard part is done, so now we're going to find this. And again, all we have to do is take the square root of it. It's not usually going to come out to be a nice whole number. In fact, I wouldn't guess it to be. Square root of 19.6 calculator tells us that is what? Yep, I would go with 4.4. And that's all the further I'm going to talk about standard deviation for today. When we get further on in the semester in a month or two, we'll talk about what this value actually represents. Again, for right now, all you need to know is that it's the spread of the data, how close these numbers are to one another. Variance is kind of a goofy formula, but at the end of the day, it's just a formula. Okay, if we can plug them in, simplify, we got it. Moving on, a data value that is far removed from the rest of them. Okay, and it's called an outlier. It's the one that stands out, black sheep. Here we want to identify the outlier of the set, which I think it's obvious, 68. And what we want to do now is we want to find the range with the outlier as well as without it. If we find the range with it, what is it going to be? Yep. We find it without.
No, sorry.
There you go. And what would be the benefits of doing that? I mean, to me, if I'm going to present this information to somebody, I'm not going to say, yeah, we had a really big range of 66. But I would also point out the fact that, if we removed one of these test scores, our range was actually quite close to one another, actually within 4. So I think the 4 would give us a better representation of what's taking place as opposed to that 66. Last thing we need to do. We need to draw a box and whisker plot to display the data. So box and whiskers. When we do box and whiskers, we need to start by putting our numbers in order from least to greatest. So help me out. What's the least number? Then what do we have? And if I had these numbers on a test, I would be crossing them out as I went along. Also, if you want to, in the book, you could count how many you have. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just to make sure you didn't lose one or double up on one as well. We have our numbers in order from least to greatest. Now we're going to go ahead and begin. Start by identifying your min and your max, which is your least and your greatest. So there they are. Next thing we want to find with the box and whisker plot is the median. So the middle number, or middle value. And there are 2 more points that we need to find, and they are called the upper as well as the lower quartile. Lower quartile. It is simply the middle number that occurs between our min and our median. So therefore it's the 22. Lower quartile. Upper quartile, it's the value that occurs between our median and our max. Therefore 32. So when somebody asks you to create a box and whisker plot, What are you really finding? Well, you're finding the medians. And what you're doing is you're taking your set that you have and you're dividing it into 4 groups. Here's group number 1, here's group number 2, here's group 3, there's group 4. You're dividing it into 4s. We go ahead and create our number line. Lowest value is 20, and I need to go up to 35, so what would be a good scale to go with? I would go by 2s. There's 22, there's 24, there's 26, there's 28, there's 30, 32, 34, and 36. I'm good with that. And now what we want to do is take our 5 points that we found and we want to go ahead and plot them right above the number line. So we have 20, 22, 29, 32, 35. The box goes in the middle. Vertical line right through that point if you want to. I should have been over a little bit further. Whiskers on the outside. Sometimes what they'll do for you is they'll go ahead and give you the exact values if our scale happens to be smaller. So they will write these numbers on top. That way there's no confusion as to what they are. So let's ask a few questions off this. What percent of the class scored between a 20 and a 29 on the test? Thoughts? Well, if we identify where 20 and 29 is at, right there to there, right? That would be half of our values, so 50%. Here's 25, here's 25%, there's 25% of our scores, there's the other 25% of our scores. What percentage of our students scored between a 32 and a 35? 25%. Good. How about 22 to 35? 75%. Okay. What percentage of the students scored between a 20 and 22? 25%. Okay. So box and whisker plots again is nothing more than taking the numbers that they give you and putting them into 4 groups. Okay, dividing them into 4s. So you got your 25%, 50%, 75%, and 100%.